Hello friends and welcome to edupediaworld.com, your destination to online education. Friends, today we are going to learn about the discovery of electron by cathode ray experiment. But before starting with the new session, let's revise the last session where we learned about the structure of atom. As we know, there are three fundamental particles of atom called proton, neutron and electron. Where proton and neutron resides in the nucleus of atom, you can see here in this diagram. An electron which is outside the nucleus revolves around the nucleus by a fixed circular path. We call it an energy level or an orbit. Here, if you talk about the charges, proton have a positive charge, electron with a negative charge, neutron with a no charge, that it is a neutral. So the next topic which we also learned about is the mass number and atomic number. What is mass number? It is nothing but the summation of proton and neutron present in the nuclei of the atom. And the atomic number, it is a number of protons present in the nuclei of the atom. You can see, friends, here I have taken the example of carbon, where C is the symbol of carbon, and the 12 be the mass number, 6 be the atomic number. So come up to this new session. We are going to learn about these topics. The first is the discovery of electron by cathode ray experiment. We are just going to brief out the whole experiment. Then we will be knowing about the person behind this experiment, J.J. Thomson. Then we'll start with the experiment with the construction of equipment, then the properties of cathode ray and the formation of cathode ray. And last but not the least, the properties of electron, which are actually discovered in this experiment. So let's go. Discovery of electron by cathode ray experiment. How? The existence of electron in an atom was actually shown by J.J. Thomson in 1897. He passed an electricity of a high voltage through a gas at a very low pressure. Why did he do this? He just wanted to pass an electricity energy to break down the atom of a gas into very small particles, and the apparatus he used is the discharge tube. You can also call it a cathode ray tube just because the cathode rays are formed in this experiment. So let's start with the learning of the person behind this discovery. He's a J.J. Thomson. We actually know him with this name, and the full name is the Sir Joseph John Thomson. He was born in 18 December 1856 in UK. He discovered electron isotope and also invented mass spectrometer for us. He was awarded with the Nobel Prize in Physics in 1906 and was also knighted in 1908. So let's start with the experiment with the construction of equipment with the discharge tube. So here you can see the diagram of a discharge tube. Let's take a marker first and highlight the main point. This is a discharge tube. It is basically made of a glass, right? This is a metal electrode. This is a negative one made up of metal. This is also electrode, that a metal electrode, the positive one called anode. This is a vacuum pump used to adjust the pressure in this gas in the discharge tube, right? This is a high voltage generator. Right? The straight lines you see here are the cathode rays. Right? Now let's describe the apparatus and see the different observation taken by the J.J. Thomson. So Sir J.J. Thomson has taken three conditions. Let's write down one by one and what happened with the discharge tube. First, he took three conditions between the voltage, which he kept fixed, and keep changing the pressure of a gas in the discharge tube. So first condition he put pressure with 1 atmosphere, right? So what will the result he get in the discharge tube? That is no electricity is flown in the tube, right? And second condition, what he does is he has kept voltage fixed, that is a 1000 volts, right? And pressure is being slightly decreased by 1 mm of mercury. What the result he get? The electricity starts flowing, right? In third condition, what he did, the high voltage is again kept fixed, right, with the 1000 volts, and the pressure is again decreased by 0.001 mm of mercury. Now what he get the result? He get the electricity is flowing and a greenish light at the end of the discharge tube is seen. Like let's make this is a discharge tube, right? This is a cathode. This is a negative one. This is the anode, positive. These are the cathode ray lights. This is a vacuum. So what happens in the third condition? The cathode ray starts moving to the positive end, and here when we decrease the pressure, here you can see a greenish light is being seen here at the end of the discharge tube. Right, so this is a construction. So it is now known that some invisible rays are formed at cathode, and when these rays strike the glass tube, they emit a greenish light. Since these rays are formed at the cathode, so they are known as cathode rays, right? So these are cathode rays. So let's come up to the properties of cathode ray. So what is the property of cathode ray? First is the cathode ray can travel in a straight line. Second, cathode ray can produce mechanical effects. Third, cathode ray are negatively charged. Fourth, the nature of cathode ray does not depend on the nature of a gas. Fifth, the mass of a cathode ray particles is very small as compared to the mass of the atom. Let's explain by some help of examples and diagrams. So, what is the first property? It says that the cathode ray travel in straight line, right? Let's make an diagram of the discharge tube experiment. This is a cathode, right? Metal plate, negative plate, cathode, electrode, right? So the property is the cathode ray travels in a straight line. How we prove this? Let's keep a positive sign of a metal body here in the path of the rays. So what happens when the rays falls on this plus sign? There's a big shadow at the end of the tube of this. Yes. So this is the shadow of the metal cross. So here you can see that when an opaque object is like a metal cross is placed in the path of cathode ray in a discharge tube, a shadow of metal cross is formed at the end opposite to the cathode, right? So this shows that the fact that cathode ray casts shadow of the object placed in their path shows that the cathode ray travel in a straight line. So if we prove the second point, which is cathode rays can produce mechanical effect. So let's explain by the diagram. Again, I'll make a discharge tube diagram. This is a discharge tube, right? Let's suppose this is a cathode, negative electron, and this is a positive anode electrode. And here are the cathode rays lines which travels in a straight line. Cathode rays. Now let's keep a wing just in the middle of the tube so that The wing's upper part strikes with the cathode rays, right? So if a light paddle wheel travels the mica blade, this is a mica blade, right? When these travels in the upper part of the mica blade, what happens? The wheels start rotating, right? Thus, the paddle wheel can be rotated only if the cathode ray consists of material particles having a mass and kinetic energy. So this have a mass and kinetic energy, right? For example, if we want to push a stone, we have to make a force, or we have to make a energy to push the stone to the forward side. So we should have a mass and kinetic energy both, so that we can push the object into the forward direction. So here also the cathode ray have a mass and kinetic energy to push or to rotate this mica blade wheel. So this shows that the fact that cathode rays are a beam of particle having a mass and kinetic energy. Also, it shows that the cathode ray can produce mechanical effect like to the rotation of light paddle of wheel. So now let's understand the third one, which is nothing but that the cathode rays are negatively charged. How? Let's again understand by the help of example and the diagram. This is a discharge tube I'm making again. This is a cathode electrode. This is a positive, that is a anode electron. Let's suppose there is an external electric field applied at the center of this discharge tube. So what happens? As we know, the cathode ray goes from the negative to positive electrode, like as we have seen in the first property. It travels in a straight line. Why? Because the anode is just opposite to the cathode electrode. So if we keep some external electric field with the positive end here and negative end here, what happens to the cathode rays? These are the cathode rays. The cathode ray will bend towards the positive, like this. Why? As we know, opposite charges attract. So if it is a positive, it has to be negative. So what is the conclusion with this property? As when an electric field is applied in the path of cathode ray, they are deflected towards the positive plate of the electric field. We can see here in this diagram. So cathode ray can be deflected towards the positive plate of the electric field only if they have a negative charge. As we all know that positive and negative, that is opposite charges, attract each other. So the fact that cathode rays are deflected towards the positive plate of an electric field shows that the cathode ray are made up of negatively charged particles, that are electrons. As cathode rays are also deflected by a magnetic field, and the direction of deflection of the cathode ray in a magnetic field also shows that they consist of negatively charged particle in a motion. I hope you have understand these properties. Now let's come up to the formation of cathode ray, how the cathode rays are formed in this whole experiment. We have just understood by the help of above, above topics. So let's brief out how the cathode rays are actually formed. First, that the gas is taken in the discharge tube consisting of atoms. As we know, all atoms contains electrons. When we supply high electrical voltage, the electrical energy push out some of the electron from the atom of a gas. What happens then? Then these electrons form a cathode ray. So the formation of cathode ray shows that one of the particle present in all the atom is a negatively charged electron, as we have discussed earlier in this slide. Now let's start with the properties of electron, which have just formed in these slides. First property is the mass of the electron, which is nothing but the 1 by 1840 of the mass of hydrogen atom. And the absolute mass we can say is the 9 into 10 to the power minus 28. So we conclude is that the mass of an electron is about 1 by 1840 of the mass of hydrogen atom, which is actually the lowest mass of atom. Since the mass of hydrogen atom is 1 AMU, so we can also say that the relative mass of an electron is 1 by 1840 AMU. And the absolute mass we can say is 9 into 10 to the power minus 28 grams. So in second property is the charge. As we know, electron is negatively charged. So what is the charge basically on the electron is the 1.623 into 10 to the power minus 19 coulombs. We can also say that the relative charge of an electron is minus 1. So the conclusion we come up is the absolute charge of an electron is 1.6 into 10 to the power minus 19 coulombs of negative charges. As this charge has been found to be the smallest negative charge carried by an atom particle, so this is taken as a unit of negative charge. So this means that an electron has a 1 unit of negative charge. In other words, we can also say that the relative charge of an electron is minus 1. I hope you have understand now the properties also. So let's come up to the conclusion of this whole experiment. Let's write down the conclusions one by one. Let's change the color so that you can see in the right manner. So what is the conclusion? First, we came to know that cathode ray consists of negative charge particles, right? We call it electron. You know that electron has given the name by a scientist Johnson Stoney. These negatively charged particles are an integral part of an atom. That is, they reside in the atom, right? And electron have both definite mass and charge, right? Both of which are independent of the nature of a gas in a discharge tube. That is the independency nature of the gas used in discharge tube. So this is how the electron has been discovered in the experiment of cathode ray. So now I end up with this session. Now it's your time to go into the activity. You don't have to do any homework. You just have to view this video at least by 3 times so that you can understand it more clearly. So here I end up with the discovery of electron. Let's meet in the next session with the discovery of proton. Thanks for attending this wonderful session of discovery of electron by cathode ray experiment. Thank you very much.